An equation has an equal sign, and an inequality has either these four signs: less than, greater than, less than or equal to, or greater than or equal to. And today, for this video specifically, we are going to talk about quadratic inequalities. So let's start off with a simple example here. We are going to find a range of x so that x squared minus 16 is less than 0. Now, in terms of graph, you can start to imagine here. X squared minus 16. It is basically the graph of y equal x squared, and then you just translation of moving downwards by 16 grids or squares. And so for y equal x squared, the y-intercept is 0. So x squared minus 16, the y-intercept should be negative 16. In terms of algebra, we can simplify x squared minus 16. So we can do like that, x squared minus 4 squared, so that we can factorize it like that, x plus 4 multiplied by x minus 4. And in terms of graph, this is how it looks like for y equal to x squared minus 16. Now if we let x squared minus 16 is equal to 0, then we will have the roots of 4 or negative 4. And there will be y-intercept of negative 16 here. So now we are going to find x squared minus 16 is less than 0. X squared minus 16 is less than 0. So you can see here, for the range of x, to let that happen, it must be in between here. It is in between 4 and negative 4 for this curve to be less than 0, to be underneath the x-axis. So we can conclude that x is in between negative 4 and 4 for this to happen. Well, what about the opposite? What about what if you want x squared minus 16 is more than 0? So it's the same thing in algebra, it's like that. And this is the graph is exactly the same, but this time we are going to make it more than 0. So it is above the x-axis. So these are the portions we want. X less than negative 4 because it's above the x-axis, and x is more than 4 because it is also above the x-axis. So for this, we can conclude that x is less than negative 4 and x is more than 4 for this to happen. So this example here is way more complicated than the previous one, because now we have 4x squared plus 6x plus 7 is greater than or equal to 5. So let's imagine a graph first. So on the left hand side we have 4x squared plus 6x plus 7. That is a quadratic curve, and we have the ability to sketch a quadratic curve. So it should not be an issue for us. And then on the right hand side, it is just 5. So you can imagine a horizontal line of y equal to 5. And that's a quadratic curve. And this is the case. There's a curve, quadratic curve, is a U shape because the coefficient of x squared is more than 1. More than 0, it is positive. And then there's y equal 5, the horizontal line. And now we want the curve is more than y equal 5. So we want the portions of the curve that is above this y equal 5 line, which is like that. And one thing that is really important here is the intersections between the curve and the line. So how are we going to find the intersections? And then we are going to deduce the curve is above y equal 5. So first of all, let's just minus 5 on both sides. Now what does this do to the graph is that both the curve and the line will translate downwards by 5 grids or squares. Just to make sure, just to essentially make y equal to 5, when it translates down by 5, it will become x-axis. And the curve will move down by 5, so that essentially everything just does not change, but everything just moves down by 5. And so let's do that. So we have 4x squared plus 6x, 7 minus 5 plus 2 is greater than or equal to 0. Now we can factorize 2 here because we have 4, 6, 2, which is multiple of 2. So let's just take out 2. So 2x squared plus 3x plus 1 greater than or equal to 0. Right. Now can we factorize this inside the bracket? I believe we can. Yeah, we can. 2x plus 1 multiplied by x plus 1 is greater than or equal to 0. Just to make sure it's correct. Yep, it is correct. So if you just make it to equal to 0, just to find the roots of this quadratic equation, x will be equal to negative half and x will be equal to negative 1. So we can draw a graph here to illustrate what is happening. So I'm going to draw a line, and this is our curve, and here this is negative half and this is negative 1. This is the x-axis and y-axis is somewhere to the right. So we want the curve to be more than or equal to 0, which is above the x-axis. So we want the portion here. The curve is above the x-axis. And so we can conclude that here x is less than or equal to negative 1 and x is greater than or equal to negative half. And so that is our solution. This will be the range of x, so that 4x squared plus 6x plus 7 is greater than or equal to 5.